Okay, so today looking at something new, looking at what's called percent composition by mass. We're going to be able to solve percent, basically how much of a compound is made of a certain element. So in this first example, they're talking about rust. So how much of the rust is iron and how much of the rust is oxygen? We're going to be able to solve this with grams. We'll be able to solve it with moles, and we'll be able to solve it with formulas. So first thing we're going to look at is grams. Now, I do want to note that grams and moles solve the same exact way. So this particular situation, we have grams, but this could say 1.26 moles and 0.54 moles. It will solve the same exact way. So grams and moles are going to solve the same way. So first thing, we need to get a total. And so the way you're going to get the total is you just add up whatever they give you. So in this situation, they gave us 1.26 grams of iron and 0.54 grams of oxygen. They could have had 3 masses. The chemical could have more elements in it. It could have 4 masses. It doesn't matter. You're going to take each of them and add them up. So we got 2. Let's just add them up. So we're going to take 1.26 and we're going to add that to 0.54. And that's going to give us 1.8. And again, this could be moles, and it would solve the same exact way. So we're just going to get a value there, 1.8. Now that's going to be our total mass. It could be total moles, it could be total mass, but that's going to be our total. And so we're going to use that number as we solve the problem. And so basically, to figure out what we need, everything is going to be divided by this value of 1.8. So you're going to end up with a percentage for each element. In this case, we have 2 elements. So we're going to have a percent iron, and we're also going to have a percent oxygen. So let's do the iron first. So percent iron is going to be the mass of the iron, which is 1.26. That's just the iron, divided by the total, which is 1.8 grams. And so there's your total. So this is the total value. And when you're doing this, you don't really need those. I'm just trying to show you how it works. And when we run it through, we're going to get a value, but since it's a percent, we're going to want to multiply our answer times 100, and that's going to give us a percent. Okay, so 1.26 divided by 1.8 times 100. So let's go over here. We'll go 1.26 divided by 1.8 equals 0.7, and then you're going to multiply by 100, and you're going to get 70%. So that means 70%. So 70% of this chemical is iron. So if there's only 2, which there are only 2, you could just take 100 minus 70, and whoop, that's not 70. Try that again. 100 minus 70, and that's going to give you 30%. Okay, now you could also double check and do the math, and you will have to do the math if there's, let's say, 3 parts. And so just to show you the math real quick, if I was doing percent of the oxygen component, then the way that would work is I would take oxygen's number, which is 0.54, 0.54, and divide it by the total, which is still 1.8, and multiply it by 100. Now this is supposed to give us 30%, right? Because we got 70 there. We're supposed to get 30%. So we can double check 0.54 divided by 1.8. So 0.54 divided by 1.8. And okay, that's great. We got what we were hoping for. And there you go, 30%. And so that would be the 2 percentages. And so in this particular answer, you'd be looking for 2 things. One of those would be the 70%, and one of those would be the 30%. And they add up to 100, which is what we're looking for. Now, if it doesn't add up to 100, then you probably got something wrong, or you need to round. Sometimes you have to round a little bit to get it to 100. But when you round it, you should be rounding a very small amount. You shouldn't be rounding a significant amount. So, okay. Again, when you see something in moles, it's going to solve the same way. And so if we slide down here, we can take a look at moles, and it's going to solve the same way. So take a look here. We've got 1.2 moles of carbon. We got 3.2 moles of hydrogen. It's still asking for percent composition. So you're going to solve it the same way as we did above, looking for totals, and then looking for 2% in this case. Same exact situation. So nothing different there, so don't really need to go over anything. So let's slide down here and let's look at how this looks with a formula. So you see down here, look at all these formulas. You've got all these different formulas, and so the formulas are going to work the same way, except we're going to use the periodic table. So we're going to do one of these, and so let's go ahead and do number 11, because these are super straightforward. So carbon monoxide. All right, so you notice there's no masses here, there's no moles here. How are we going to approach this? So we're going to approach this by looking at the periodic table. So we're going to get these values from the periodic table. And so that's where they're going to come from. You're going to get your periodic table out, you're going to look those up, and we're going to get those from the periodic table. Okay, so we need to find carbon and oxygen to figure out, again, a total mass. So this hasn't changed. We're still looking for a total because the process is the same. We need the carbon divided by the total and the oxygen divided by the total. Now, the total could get more complicated. This is a pretty simple one, but if you look like here, there's more chemicals there, and you'll practice those. But this one is going to give us the gist of the idea. So let's go ahead and go to our periodic table real quick. And so we're looking for carbon right there, and that's going to be our 12.01. And then right here we've got our oxygen, which is 16. So we're just looking for our totals. And so in this situation we got our 12.01. I'm not sure why it's not highlighting, but that's okay. And our 16. Okay, well, that didn't work that well, but that's fine. So we'll go back, and we got 12.01 and 16. So what we're going to do is we're going to add those up. We got 12.01, and we got 16 for oxygen. And so then that's going to give us our total, which is 28.01 grams. Okay, so the total is 28.01. And so what you do is, this was carbon and this was oxygen. You do the same exact thing, except for these are the values that you're going to use. So we got 12.01 for carbon divided by 28, and 16.00 for oxygen divided by 28. Now, if you had more carbons, you'd have to multiply by however many you had. So let's say you had 3 carbons, you'd multiply it by 3. Had 3 oxygens, you multiply it by 3. So you look at the total mass. So if we go down to this one, that's going to be 6 carbons. So it's not going to be 12.01, it's going to be 12.01 times 6. So again, solves the same way. We're going to have 2 values. So I'm going to do, I'll just do it up here. We're going to have our percent carbon, and that's going to be our 12.01 divided by our total mass, which is 28.01. Again, all from the periodic table, and we'll multiply that by 100. And then our percent oxygen is going to be 16.00 divided by 28.01 times 100. Now again, we are hoping that we get answers that are adding up to 100%. And so let's go ahead and clean this up a little bit. And we'll do the math. So 12.01 divided by 28.01 equals, and we'll multiply that by 100. And so at this point, you got to decide how you're going to round. So you could go to a whole number, so 43. You could go to 42.9, really up to you. If you look at what we started with, we've got, four values. So you could go to 4 sig figs, but it doesn't really matter. It's just up to you. So I'll just go to 43% on this one. So make it easy for us. Again, you could be more accurate if you wanted. So that one is 43%. And so again, you could just take 100 minus 43, but we should also probably check. So make sure that we get what we want. So 16 divided by 28.01, enter, multiply by 100, and you can see, oh yeah, 57. But again, rounding to the whole number should be consistent, right? You don't want to have a decimal in this one and to a tenth, and this is not to a tenth. That's not going to make sense. So 57%, and so it's like, okay, that's great. This is good stuff. We're at 100%, and so there are your two numbers. So again, your answer here has 2 percentages. So, okay, going through these are obviously going to be more complicated. You just have more pieces, so like you've got 3. You got 3 carbons. So like on this one, when you were running this through, it'd be 12.01 times 3, not just 12.01. And then the hydrogen is going to be like 1.01 times 7. So just have bigger values. This one also has another hydrogen there, so it's actually not 7, it's actually 8. And then, so you got to kind of be careful. So even though those hydrogens are spread out, they all kind of add up. This one also has a total of 3 chemicals. So this one would actually have 3 different percentages, not 2. So you can work through these. Some of them will kind of talk about the chemicals. So that's talking about aspirin. That doesn't really matter. It's just, again, you got a carbon percentage, a hydrogen percentage, an oxygen percentage. So pretty straightforward. Shouldn't have any trouble. If you do, just save those questions and I will answer those. But you should have at least be able to get a start on this. I guess one last thing again, moles, grams, or a formula, they are all going to basically use the same problem-solving strategy. Your value of what you are trying to find divided by the total. So, all right, hopefully this is helpful.